10th Physical Science class lesson classification of elements, the periodic table, topic Mendeleef's periodic table. So Mendeleef is a third scientist, wants to group the elements in the world. So Mendeleef is a third scientist. Before him, Daubernier and Newlands tried but failed in group of the elements. But Mendeleef formed the periodic table here. So here Mendeleef drawn on a chart vertical lines and horizontal lines. So by a drawing vertical lines and horizontal lines, 8 groups are formed and 12 periods are formed here. Group 1, Group 2, Group 3, Group 4, Group 4, Group 5, 6, 7, 8. So the numbers given for groups appeared as a Roman numbers. Next, in the periods 1, 2, 3, 4, 5, 6, 12 numbers given, it appears as a Arabic. By using atomic weights, so one by one the elements atomic weights are increased. So by increasing the order of the atomic weights, so the elements are arranged group wise and period wise. So in the first group we see the hydrogen 1, lithium 7, sodium 28, potassium 39. So the atomic weight increased here. So on the basic of the increasing atomic weights, the elements are sitting here: hydrogen, lithium, sodium, potassium, according to the increasing the atomic weight. When we see the period wise, lithium 7, beryllium 9.4, boron 11, carbon 12, nitrogen 14. So here also we can see the increasing the atomic weight and placed side by side. The elements are arranged towards the periodic wise. Next one, in the every group, Mendeleef divided 2 parts, A, B, A, B, E, A, B. So in 8 groups, we can see the parts, 2 parts, A, B, A, B, A, B. Like this, every group is divided into 2 parts and given A, B. So below the A, some elements are there: hydrogen, lithium, potassium. And below B, we can see the sodium, copper and silver. So like that, below the all groups, we can see the towards the A, some elements are there, towards B, some elements are there. Next, Mendeleef arrange the elements in the increasing order of their atomic weights. So here we can see the group wise and period wise. We can see the increasing the order of the atomic weight. He formed a vertical columns known as a groups. Again, each group is divided into A, B subgroups. So here we can see the main groups and subgroups A, B. Horizontal rows are called periods, horizontal lines. We can see here 12 horizontal lines are there, and these are called periods. The elements present in a group have a similar chemical properties. The element along the periods have a different properties. So in the group wise, hydrogen, lithium, potassium, rubidium, so the elements present in the group have a similar properties. So all these are metals. Next, when we see them towards the periods, lithium, beryllium, boron. So when we see the period wise elements, the properties are different. So some are metals, some are gases. Okay, so oxygen is a gas, fluorine is a gas, but carbon is a non-metal, and lithium, so metal. So like this, towards the period wise, the properties of elements are different. First group elements, lithium, sodium, potassium, when they reacted with the oxygen, according to formula, compounds are formed here: lithium oxide, sodium oxide, potassium oxide. So first group elements, hydrogen, lithium, okay, so they are reacted with the oxygen according to formula. So already Mendeleef given a formula: R2O, RO, R2O3, RO2, R2O5, RO3, R2O3, RO4. All these are formulas given in the formula by the Mendeleef scientist. And second group elements, beryllium, magnesium, calcium, second group elements. So here also we see here. So these elements also reacted with the oxygen by using RO formula and forms compounds like beryllium oxide, magnesium oxide, and calcium oxide. Okay. So when we see the all similarities by group wise elements and periodic elements, so the Mendeleef state one formula, periodic law. The physical and chemical properties of the elements are periodic function of their atomic weights. Periodic functions means the functions are repeated so along the atomic weights. So this is called periodic law. And groups 1 to 8 appeared as a Roman numerals. So here given the groups numbers in the form of Roman numerals, periods 1 to 7. So modified Mendeleef, 7 periods are there, and before 1 to 12 periods are there, and these are appeared as a Arabic numerals. Okay. After modifying this Mendeleef period table, we can see the change in the periodic number. 1 to 7 is there, and before 1 to 12 is there, and also here we can see the 8 groups are there. Before also 8 groups are there. Okay. When the Mendeleef modified this period table, we can see the achievements of Mendeleef. Achievements of Mendeleef means first scientist Mendeleef formed the groups and periods, and by using the atomic number, he placed the in all elements in the group wise and period wise. Next one, predicting missing elements. Mendeleef leave the some space for unknown elements and given the name for it as a eka-boron, eka-aluminium, eka-silicon. Only properties them predicted but not a element, particularly not discovered. Later, scientists discovered element for eka-boron, eka-scandium, eka-aluminium is a gallium, and eka-silicon is a germanium. Okay, so first Mendeleef's period table, when we see after boron there is a no element. So Mendeleef given eka-boron. After aluminium, no element is there. So unknown element is there. So Mendeleef given this one eka aluminium. After silicon, no element is there. So Mendeleef given this eka silicon. So after discovering elements, so in the modern period table we can see the eka boron is a scandium, eka aluminium is a gallium, next eka silicon is a germanium. Okay. Next one, correction of atomic weights. The correct placement of elements in Mendeleef period table helped in correcting in atomic masses of beryllium, indium, gallium. So here we can see beryllium, indium and Rm. Rm means gold. So he corrected the atomic mass of elements. Without knowing the electron configuration of the atoms of elements, Mendeleef arranged the elements nearly close to the arrangements in the modern period table. Same group of elements have a similar properties. That is why he can arrange the elements close to modern period table. So after this modified Mendeleef period table of elements, some new scientists formed the modern period table. But there is some similarities for Mendeleef period table and modern period table. Okay. So at the time of Mendeleef, no electron configuration is not there. Extraordinary thoughts used by Mendeleef period table and placing the elements in the correct position of the groups and periods. And some limitations are there. Limitations, drawback. So here we can see the limitation of Mendeleef's period table. First one, anomalous pair of elements. Higher atomic weight of tellurium placed before lower atomic weight iodine. So tellurium atomic weight is more and iodine atomic weight is lower. But here we can see in the 7th group, tellurium is there, iodine is there. Tellurium atomic weight is more, iodine atomic weight is lower. So in the all elements sitting in the correct position of the period table, okay, increasing the atomic weight. So they are arranged here. But here we can see first tellurium atomic weight is more than iodine. So here tellurium is placed before the iodine. So it is a drawback in the Mendeleef period table. Next one, dissimilar elements placed together. Dissimilar elements means different properties contain elements. Lithium, sodium, potassium are alkali metals, and copper, silver, Rm are coinage metals. Their properties are different but placed in same group. So here we can see here in the first group, sodium, potassium, rubidium. So these are alkali metals. And copper, silver, Rm. This is a coined metals. So different properties are there. But Mendeleef placed these elements in the same group. This is a drawback. Chlorine is a gas, manganese is a metal, but kept in a same group. So here we can see chlorine, manganese. Chlorine is a gas, manganese is a metal, but Mendeleef kept these two elements in the same group. Okay, so this is also drawback of the Mendeleef's period table. But so many properties are similar to Mendeleef's period table and modern period table. So many scientists are agree with the Mendeleef's periodic table. Okay, thank you.